Welcome to the NPTEL Massive Online Open course on Phonetics and Phonology, a broad overview. And we are continuing with our Unit 7, where we have talked about phonological alternations, about finding underlying representations, about ordered rules. And in this section, we will continue with those discussions and not just talk about phonetic alternations, phonemic alternations, but also look at what happens when there's a lot of morphological complexity in the data. So as we have already talked about in the lecture on phonological alternations, the UR, or the underlying representation, it is not there on the surface, so it is not surface apparent, and therefore it is also known as hidden structure, which has to be always discovered in a data set. So it is not something which is phonetically realized, and therefore it must be inferred from the surface representations as what you see in the data as your consonant and vowel combinations. That is your surface representation, and the UR has to be inferred from this data. So the UR is not there in the data that is presented to you, or not there when you hear speech. That is not the underlying representations that you hear. So in a phonological analysis, you try to understand hidden structures. So again, as we have discussed before, the underlying representation of a morpheme contains only the unpredictable morphological information about that morpheme, and the information is unpredictable. But how do we know which information is predictable and which information is not predictable? And the answer is entirely in the analysis, and we will see in more detail today how we can proceed with that analysis. When we talk about alternations, both phonological alternations and morphophonological alternations, something which is of utmost importance is rule ordering. When there are multiple rules in the data, we have to decide if these rules interact with each other, how to order those rules to arrive at the correct outcome. So when you're doing an analysis, phonological analysis, we not only find out rules, we also have to find out if there are, to analyze a given set of data, we need more than one rule, and if we have more than one rule, do they need ordering? Is it necessary to place one rule before another rule so that one rule applies before the other rule? And what is the order of two given rules? And if they have to be ordered, that means that the rules interact for the given set of data. So we will not talk about phonological alternations now. We will talk about morphophonemic analysis. And what is a morphophonemic analysis? It seeks to, what does it do? It seeks to establish a connection between the data and theory. And of course, because it is about morphophonemic analysis, it is data, phonological data with morphological complexity. And the purpose of morphophonemic analysis is to discover a set of underlying forms and ordered rules that is consistent with the data. So as we just discussed, the two important things here would be underlying forms and ordered rules. And complex patterns can be described with great simplicity if we find the underlying patterns, the underlying forms, and see how rules are applying to those forms to give us the surface representations. And morphophonemic analysis may be contrasted with phonemic analysis, which we looked at in the previous lectures. What happens in the phonemic analysis? It is only about phones and phonemes. But morphophonemic analysis involves morphological complexity, data which is morphologically complex. What is the procedure for morphophonemic analysis? We have to, of course, examine the data. We have to look at the glosses and make provisional division of the forms into morphemes. So we have to make some what is known as morpheme cuts. And find each morpheme that alternates and locate all of its allomorphs. So also we have to see if there is alternation in data. And within each allomorph, locate the particular segment or segments that alternate. And once we find the allomorphs, we have to locate the regularity of a process. We have to look at the segments which are alternating. And then we have to set up the underlying representations so that all the allomorphs of each morpheme can be derived from a single underlying representation. Remember, this is like what we did for phonemic analysis, but here this has to be extended to morphemes, to more than one morpheme in a word. So like any analysis, here also we have to do some pre-processing. So how do you pre-process the data? It is always easier to do morphonemic analysis with data that are already expressed as phonemes. So if they are not, then there is some further difficulty there. And we have to make the morpheme division, the morpheme cuts, and we have to break up the forms into their component morphemes, not just the phonemes, remember, the morphemes. And as the words are divided into morphemes, it is possible to state and order the rules of morphology that are active. And setting up of underlying representations is the problem of choosing underlying representations often involve considering more than one hypothesis. And suppose segment A alternates with segment B in the data, the analyst should consider two possibilities. Segment A, segments showing alternation, A, B alternation, underlyingly A, which is converted to B in certain context, the rules apply and become B by one or more phonological rules. And this is one possibility, that what is the unit which is changing? It's A which is changing to B. This is one possibility, as is the case with all phonological rules. If there is alternation, something changes to something else. And segments, or the other possibility is that when you see an alternation, that A, B alternation, the other possibility is that the underlying segment is not A, but it's B, which stays as B and in its context, but is converted to A in certain other contexts by one or more phonological rules. So we have some data from Chimwini. All the data and analysis is from Hayes 2009. So Chimwini has many instances of long vowels alternating with short. So we have the data of we have the soma to read and somo to be read. Now we have this long vowel here, we have this long vowel here, this long vowel here is shortened. So now the problem in front of us is that we have two versions of the vowel O here, right? So we have to now find out from the data if this or this is the underlying representation. So which one is the underlying form? Is it underlying a long vowel or is it underlying a short O? How do we find out this from the data? So that is how always questions are put before you when we have phonological data, that what is the form which is alternating, and to find out the form which is alternating, we have to find out the underlying form. So suppose we consider that the underlying form is a short vowel. So which means, as the rule applies, that all long vowels will become short in this context. So underlyingly we have a long vowel as in soma, and this is becoming short as in som over because of the addition of other morphemes here and the phonological context which is provided by that morpheme. So, the question that we have in front of us, is it shortening or is it lengthening? So, the two words that we have in front of us shows that in one context we have a long vowel and in one context we have a short vowel. So, this is our short vowel, this is our long vowel. Now, what is inducing this change? So, if it is an underlyingly long vowel, then we have a shortening. If it is underlyingly a short vowel, then it is lengthening. So, if it is an underlyingly short vowel, this is som. If it is underlyingly a long vowel, then it is som. So, it is a shortening rule. But how do we find out that it is so? There is no algorithm as such in phonology to find out the underlying forms, but there are tried and tested methods of analysis. So, constructing underlying representations under a particular hypothesis. A recommended procedure to construct underlying representations, segments do not alternate, that do not alternate can be assumed to be phonemically identical in their underlying representation to their surface representation. So, one, as we just said, the tried and tested things, one of them is that we often find segments which do not alternate. So, if there is no alternation, if for instance the language X and in that language R lengthens or A lengthens, but we have R and A, but we never find E or U lengthening in this language X, then we can be pretty much sure that this is identical. So, E and U, we never find E and U in any context to have lengthened. So, then we can be pretty much sure that they are identical to their underlying representation. Basically, no alternation means that there are no changes involved from A to B. For segments that alternate, follow the hypothesis you made about underlying forms, implementing it consistently through the data. That is another important aspect, that you not only have to apply your underlying forms to all the forms where it's alternating, but in all the forms where they're not alternating also to check whether there is any wrong predictions. So, hence we have to check underlying forms that we construct for the an entire set of data and not just for the forms where we see the alternations. So, be sure that underlying representation of each morpheme is uniform throughout its paradigm. So, you cannot have multiple underlying forms for the same surface form, but then there are other issues there which we will talk about. There can be sometimes underlying forms which are different underlying forms for similar surface forms, but that is another thing altogether. But here what we are talking about is that there should be uniform underlying forms. So, you cannot change the underlying form, or else you will be predicting different surface forms. And then we have to work out the rules. So, we have to arrange a suitable set of hypothesized underlying forms and align their corresponding surface forms underneath them. And suppose we take these forms now, this Chimwini data that we just saw some time back, where we saw lengthened vowels. Now, we have som, which is lengthening here, and we have a long A, and we add our rules. The rules, let's for the time being not tell you what the rules are, and then we get all these surface forms. So, what happened here? Here we have the same form here as in a lengthened O, and here unlike that word, here we have a long O, but we have a shortening here, and we are not telling you the rule what exactly it is, but because we have put the same underlying form, because of the application of the rule, now we can get these correct forms. Now, clue for choosing underlying representations. There is often a clue in the data to guide you, that is contextually limited contrast. And while vowel length is phonemic in Chimwini, only short vowels are allowed when more than 3 syllables from the end of the phrase or when a long vowel follows. So what is happening in Chimwini? We showed you in a few slides before that there are long as well as short versions of the same vowel, and what seems to be the same morpheme, in one place we have the longer vowel, in the same place we have a shorter vowel. So context, contextually determined contrast is something which is contextually governed contrast is something which is found quite often in phonological data. So what happens in Chimwini is that while vowel length is phonemic, which means there is a contrast between long and short A's and long and short O's, contrastive, but this contextually governed contrast, the contrast is not found everywhere. So short vowels are allowed when more than 3 syllables, when there are more than 3 syllables from the end of the phrase or when a long vowel follows. So what happens in our data here? So we have a long vowel following this. So this vowel is shortened. Again, this underlying long A. We have how many syllables? We have 1, 2, 3 syllables following it, and that's why again this is shortened. So there are long and short vowels in Chimwini, but the long vowels can become short because of certain context. The context is the following long vowel or 3 syllables from the end of the word, presence of more than 3 syllables from the end of the phrase. So such limitations are a strong clue that there must be a rule that wipes out the contrast in these environments. So now the contrast is not allowed to be seen in certain contexts. It is governed by the contrast is taken away or wiped away or removed in certain positions. And we just now saw what they are. There's a following long vowel or more than 3 syllables from the end of the phrase. So that is the limitation here. The long vowel's appearance in all positions can be curtailed by such contexts. And finally, the isolation form shortcut. The underlying form of a stem is the way that the stem appears in isolation, taking away the effects of any allophonic rule. So the underlying form, so one of the hypotheses of the underlying form is that it is the one that appears in isolation. We will see how that works out. In languages like English, stems frequently appear alone. So as in plant, planning, we have a T deletion there. Neutralization rules could apply just in case no affix is added to a stem. So the isolation form, that is here the plant, and that is occurring with its underlying form. But when we have affixes added, then we have we can have what's happened here to planting. So the affix protects the rule from the neutralizing rule. So neutralizing phonological rules are often conditioned by the word edge, that is they have environments like word. And when an affix is present, a stem will be buffered by the affix and the crucial rule won't apply. So let us see of this example of Lardil. Lardil is an Australian Aboriginal language spoken on Mornington Island. So the Lardil segment inventory is such that there's 4 contrasting vowel qualities, each occurring in short and long versions. The consonant system of Lardil has 4 different types of coronal consonants as well. So these are the Lardil vowels. We have long E short E, long U short U, long A short A, and long short r. So we have various contrasts in the consonant inventory as well. We have apicoalveolar, turner, and apicopalatal sort of retroflex consonants, and laminodental contics, and laminopalatal and velar consonants as well. So what we saw from the feature inventory in our previous lecture, we saw that among coronal consonants we can divide them into the distributed, minus distributed can be anterior or plus anterior or minus anterior, where the minus anterior could be the ones which are palatalized like chia and nya, and the plus anterior ones are the dental ones, the laminodental ones, and the plus anterior minus distributed ones are also the retroflex consonants. So what is important to note here is that among the coronal set, we have both minus distributed and plus distributed, where we have alveolar and retroflexes which are minus distributed and which are both plus anterior as well. But in the plus distributed set, we have the dental and the palatalized consonants. So a big inventory of coronal consonants in Lardil, which can be divided based on their featural properties of minus distributed, plus distributed, and plus and minus anterior. So data analysis of Lardil, you can see that Lardil nouns inflect for tense in agreement with the verb, and there are two inflected forms, the accusative non-future and the accusative future. So we can see that the uninflected forms do not have any affixes, and the accusative non-future has these affixes, and the accusative future has these. Okay, so now let us see what morphological rules that we have in Lardil. In Lardil, when we have noun and accusative minus future, we have this morpheme. When you have noun plus accusative plus future, we have this morpheme. Okay. Now, with that knowledge, let's move on and look at more data from Lardil. So what we see that in the uninflected form, we have one affix here. We have one sort of change there which we did not see in the data previously. So we did not see a final R in the uninflected forms. Okay. And also here, because we have R, now interesting things are happening here. We do not get the E here, and we do not get the central vowel here. Those are missing in the accusative non-future and accusative future. So we have now, as you remember from your English data where we discussed allomorphs, now we have allomorphs in Lardil. So we have in versus na, and r and just a r. So we have these two allomorphs. For the accusative non-future and accusative future, we have these two allomorphs. So another common thing that is seen in languages is that when we have a vowel ending and then the following suffix also ends in vowel, then there is deletion. There may be deletion of one of the vowels, because the structure where two vowels occur in the same place is often avoided in languages, and languages try to have one syllable there instead of two. So vowel initial syllables are avoided most of the time, and that's why we have vowel deletion, and that's why also we can see that E and O are deleted because the final are in the uninflected form. Okay. Now that is one way of thinking about the data, that the E and O are deleted. What is the other way of thinking about this? That this na and this rhotic, they are the underlying forms. So which is the underlying form, this one or this one? Okay, now we can work with both the hypotheses to see which one is effective to help us analyze the data that we have. So to verify that, let us now have our affixes with the vowels across all the forms. So remember when we said that you have to use the same underlying form across all your data. That's what we're doing now. And now when we do that, and we have to add our rule X, which says that remove the vowel, two vowels, two consecutive vowels, and let us see whether we get our surface forms. So we get the surface forms. We add this rule, we apply this rule, and we get our surface forms. So we are saying that this is a rule of deletion. So delete a vowel, and in a situation where there are two vowels, one after the other, delete a vowel after a vowel. Okay, the other option with us is that the hypothesis 2, that the underlying form does not have the vowel, the underlying affix does not have the vowel, and the vowel is inserted because of two consonants occurring together. So now when we do that, what do we get? So if we say insert a vowel, if there are two consonants together, then we would get these forms as before. Now there seems to be no principal basis for making this prediction. While we have no trouble where the vowel should go, breaks up word final consonant sequences, there is still a problem determining which vowel should be inserted. Is it E or U? Now that is a crucial question here. How did we know that we have to insert E here versus we have to insert U here? There's nothing in the environment telling us that one should be E, one should be U. While there is nothing wrong in saying that we have to insert a vowel between two consonants, because two consecutive consonants are not possible in the coda position in this language, but that is a possible way of explaining this, but still we don't have any way of explanation of why we get two different vowels. And something that you can remember, that in languages there's always if a vowel is epenthetic, then the vowel would be the same in all the forms. Now we have all these forms that you see here, and the data deals with the alternation of A and U, and two analyses to be considered. The underlying forms of stems might be the same as the isolation form, that is Nuka, Kata, Ngawa, and if we add U in Nukun, so we get the form Nukun. So suppose we have the rule of vowel deletion there. Unlike what is said, the other hypothesis that we entertain of insertion, if we do not entertain it anymore, and we have this rule of vowel deletion, and then we have a rule of U insertion, then we can explain why we get Ngukun here, as we see in this new data that we have of Lardil. So far our Lardil data had these words. So we had Melan, Wakan, Kunkan, Kunkar, Melar, etc. Now we have this data where we are using where we can now consider the vowel deletion rule to be applicable, but we have some more complexity here. So what's happening here is that we do not get either this vowel or this vowel, and we get a different vowel, which is not the case in this word. So here Wanka in is the rule of vowel deletion applies correctly, we get Wankan, but in the final surface form it stays Wankan. The intermediate rule here that we have of rule X does not apply here, it does not apply, but it applies here. So what more is happening in Lardil apart from vowel deletion? So rule X converts Ngukan to Ngukun, but fails to convert Wankan to Wankun. So something to note here is that the two vowels here are different, whereas the two vowels here are the same. So what's faced with the failure from the A to U direction for the rule, we can try the U to A direction. So now let us add some more interesting analysis to the Lardil data and see what if we, instead of trying to say that A goes to U, why don't we think that U goes to A? So okay, so let's think that the data we have is not Nuka but Nuku. Okay, so So which means our underlying form is ngoku, and as a result, what we are supposed to get, we get ngoku, ngkun, and finally we get ngokun. And whereas wanka is wanka, wanka does not have to change because the final form is also wankan, so there is no problem in this derivation with wankan, but the problem is with the derivation with ngoku, because in one form we get ngoka, in another form we get ngokun. So we can draw a distinction between this set and this set, ngoku and wanka, where here we get one form is ngoka and one form is ngokun, whereas wanka and wankan remains the same. So again we can say that Lardil has something called final lowering. U goes to a in the final word position, as you see in this word in muka. So u lowers to a, and so we get muka. Lower u to a if it occurs at the end of a word. Now actually we need more data to see what's happening in Lardil. With the data that we have seen so far, we will not be able to say if there is final lowering in Lardil or not. So there is final lowering in Lardil. How do we know that? Look at this data that we have in front of us. So we have kente, we have nine, we have pape, we have kentin, we have ngingin, we have papin, we have kenti wor, we have ngin and we have papior. Okay, so when we have kent, which is the underived form, kente, note that when the form is kente, in the accusative non-future we consistently find e, in the accusative future again we consistently find e. So which means there must be a rule of lowering, which means that the underlying e must have changed in the uninflected form. So this Lardil data shows us something very significant. It shows us that morphemes here can appear in different shapes, and you can see the underlying form in a derived form, and in the inflected form you can see the underlying form and not in the uninflected form. In the uninflected form we have further phonological rule applying. So as a result, the data supports the hypothesis that final lowering is a rule of Lardil phonology. As you can see in the uninflected forms, we do not have the e, we have a, which means a lower vowel. So there is an alternation between a low and high vowel, e, as we have just discussed. And there is also another alternation with verb appearing in the accusative future suffix. So what is final lowering? Vowel becomes low. This is minus high and low, and minus back, minus round in the word final position as shown by this, the way this is written, as we have discussed rule writing before. So this rule changes round so that u will become unrounded. So the u becomes unrounded, and as a result we have changed to e in the accusative future also. So this rule, which changes u to unrounded, it does not affect e, which is already minus round and minus back. So now looking at the Lardil data, we have a couple of rules to work with. So now we have, initially if you recall, we have the first, we found that there is vowel deletion in Lardil, and then we found that there is vowel lowering in Lardil. And then we, as a result of both vowel deletion and vowel lowering, we have forms like pape appears as pape, and papin, two e's, appears with only one, papin. And similarly in vite in we have viten, where e is deleted, the e which underlyingly was there in the morpheme is deleted. So after stems ending underlyingly in e, the accusative future ending ur shows up with the elem of ur. Where did we see that? Again, let's go back to the data which we did not discuss then when we talked about Kenti. So recall that now we have were in this data. Recall that earlier in the data we did not see a were there. So let us look at the were data that we discussed before. Yes. So we here either we have the r or we have as in or here. Okay. But this form that we see here is new in the data. Were. Why do we have the glide there before the u? And that is what we are discussing here. Now, after we have gone through vowel deletion, final lowering, 2 steps, to one gives us forms like pape and the other gives us forms like papin. Now we have the rule of were insertion in Lardil. So when do we get were in the were allomorph? So when do we get that? We get that when we have e, then there's a u insertion in the suffix or, and as a result we also have the third rule, that is epenthesis of were by the following rules. So were as in null goes to were if there is a preceding e and following u. Insert were between e and u. Now we have our third rule of Lardil. So like vowel deletion, this can be seen as a what is called hiatus resolution. What does hiatus resolution rules do? So if there are 2 consecutive vowels and as a result we can have 2 syllables ending in one vowel starting with another, most of the time this sort of hiatus is resolved by any language by either deletion of one of the vowels, or epenthesis. So something is inserted between the 2 vowels, and this is also a case of hiatus resolution. And languages resolve high vowel hiatus by inserting a glide that is homorganic with one of the 2 adjacent vowels. And were epenthesis must be ordered before vowel deletion. In case the hiatus is u, were epenthesis gets the first chance, resolving it as eu. Now we have to deal with a rule ordering. When is epenthesis ordered vis-a-vis deletion? If we have a context e and u, if either of the vowels are deleted in a VV context, then there is no need for the application of the epenthesis rule. If either this is deleted, if either e is deleted, or if either u is deleted, the context for epenthesis is not there, and hence epenthesis must be ordered before the deletion of these rules. So once epenthesis occurs, vowel deletion is blocked. So now we have 4 rules for 4 vowel phonemes of Lardil: e, a, u, and a. What is our first rule? Now we just talked about epenthesis. How do we know epenthesis occurs before vowel deletion? Because if there is vowel deletion, then the context for the application of the rule of epenthesis is not there. It does not exist. Hence, it has to occur first. So we have a context for the application of this rule of the rule of epenthesis e, u. So something has to be inserted here, and we get the were in Lardil. So we have were epenthesis. We have then vowel deletion. As we just talked about, epenthesis should be ordered before deletion. If deletion was before vowel epenthesis, then in a word like papiur, there would have been no epenthesis, because then just like in papi-in, the e would have been deleted, and we would just get papiur and not papi-wur. Then we have the rule of final lowering. If this vowel is in the final word, final position, the high vowel does not occur in that position, it's a, it's lowered. And then we have our surface forms. Now we can see the surface forms of We see the underlying forms of another set. Let's apply all these rules that we have just found, the epenthesis, deletion, final lowering of Lardil, with another set of data and see how it works. So we have were epenthesis. Is there any context for the application of epenthesis? Remember, epenthesis occurs only when there is a context of two vowels e and u in Lardil. So we don't have that context here. So w epenthesis, were epenthesis does not occur. And then we have vowel deletion. We have many contexts for vowel deletion. So this, and this, and we will see that vowel deletion applies in all those contexts. And then we have final lowering, which can only apply here, which is the high vowel, and u becomes a. And as a result, we have the surface forms nguka, ngukun, ngukur, wanka, wankan, wankar. So continuing with Lardil, there's more data in Lardil which can be discussed. So we have again the uninflected forms with final consonant, and then we have the accusative non-future with pa, ka, tu, and ka, pa, tu as one of the extensions of yukar, vikar pan, ulungkan, kantu, kantun, yukar par, and wulungkar and kantu, kantur. Okay. The data shows vowel zero alternations, but also consonant zero alternations. So what happens when you see vowel zero alternations is that here all this is missing in the uninflected form. So in the uninflected forms, we see a considerable part of the form, what we think underlying form, to be missing. So similarly, it's not just vowel zero, so it's not just a vowel which is missing, it's a consonant also which is missing. So it is unlikely that the consonants could be derived by insertion, since there are different consonants that alternate. So pakata, the environment for inserting different consonants would be impossible to state, and the best analytic procedure is to set up the most likely underlying forms, run them through the rules. So we predict then that, as we talked about this, so we predict then the pa and the ka and the tu are there in the underlying forms. Okay. So if we posit that as one of our hypotheses, then what do we get? So if we have ka epenthesis, were epenthesis, then we have and vowel deletion and final lowering, and then insertion, we get a surface form which is difficult to analyze. If all our rules of vowel deletion, if you recall, the two vowels, one will be deleted, our rule of epenthesis, our rule of final lowering, if they all apply along with the apocopy, if they all apply, then our predicted surface forms would be not what we so Eucarp is not the output form in Eucarp pa. So this is which is fallen foul in our analysis. So the analysis works except where it generates Eucarp instead of the correct form, and apocopy applies freely to words of sufficient length. So when it creates a final consonant cluster, further rule eliminates the cluster by deleting the second member. Apocopy is applying freely is what we were trying to say, and it also eliminates the cluster by deleting the second member. So we have cluster reduction where C is completely deleted in a final word. So delete a final consonant, word final consonant, when it is preceded by a consonant. So now when we apply the apocopy rule properly, then followed by a cluster reduction, then we get these surface forms. So cluster reduction must be ordered after apocopy, since it is apocopy that exposes that the consonant cluster to word final position. So because of Consonant-zero, we do not see these forms in the uninflected form, and as a result we need more rules of and cluster reduction to arrive at our surface forms here. So Lardil stems alternate in a drastic way, but the system is fundamentally a simple one. The pattern of alternation reduces to a set of phonological rules applied to the output of the morphological component, and this part is very important, that alternation reduces to a set of phonological rules. So these are all phonological rules which are applying to the output of the morphological component. And also that Lardil is an illustration of the fact that isolation form shortcut does not always work. So that is something we have been talking about, that the isolation form will not give us the inflected form, will not give us the underlying forms. So we have to look at the entire paradigm to get our underlying forms.